Hello everyone. Today we're going to talk about inductive and deductive reasoning, and this is section 4.1. So I have some definitions that I want to give you. These are important. They are not in the workbook, but please write them down somewhere. So inductive reasoning is the process of arriving at a general conclusion based on observations of specific examples. We will look at some examples. And deductive reasoning is a process of proving a specific conjecture from one or more general statements. So you're given one or more general statements, as those are given statements that we assume to be true, and from those statements we will prove a general conjecture. A conjecture is a statement that has not been rigorously proved. Okay, so write these down, and so you can pause and write them down before we continue to the example. So I'm going to start working examples from the workbook from section 4.1. And let's take a look at number 1 here. Example number 1 is asking us to, let me make this straight. Example number 1 is asking us to identify a pattern and then use the pattern to predict the next items. So we're looking at specific examples, and then we're going to try to understand what's gonna happen after. What is the next case, right? So we have 1, 3, 5, 7, 9, and we need to find the next two, right? So if you observe, you want to start looking at how we go from, how do we generate the next number from the previous number, right? So how do we generate the next number from the previous number, and so on. So we look at 1, 3, 5, 7, 9, and we see that when we look at 1, the first element, what must we do to 1 to go to the next item, which is 3? So we add 2, right, and then we get 3. Then we look at 3, and if we add 2, we get 5. And then if we look at the next item, 5, and if we add 2 to it, we get 7. Right? We look at the next item, 7, we add 2, and we get 9. So we can see that consistently we're adding 2. So we can determine that the next two items will be taking 9, right? 9 plus 2 will give me 11. And then taking 11 plus 2 will give me 13. So 11 and 13 are the next two items. Okay, so that is one example. So let me erase the paper a little bit, and let's look at number 2. Okay, so number 2, so I'll do a few problems so that you can understand what we are supposed to do here. So 1, 3, 9, 27, 81, 243, and then we need to find the next two items. So let's see. Again, same process. We look at 1 times 3, and we get 3. We look at 3, and then we see times 3, we get 9. And then 9 times 3, we get 27. Okay? 27 times 3, we get 81. 243 times 3, that's going to give us 729. And 729 times 3 will give us 2,187. So then the next two items are 729, 729, and 2,187. Okay? So that's example number 2. Okay? Alright, so example number 2. Now I'll let you do example number 3. I want to consider example number 4. Okay, so example number 4 here. because this one, well, let me write it down. 1, 6, 4, 3, 7, 10, -3, 13, -6, and then the next two items must be found. Okay, so let me lower the paper a little bit. So we have 1, 6, 4, 3, 7, 7. Oh, this is supposed to be a 0 here. I'm sorry. This is a 0, not a 10. 7, 0. I think I made a mistake. Let me rewrite it. I apologize. So I'm going to rewrite this list. Okay. I'm looking at the paper here and I missed two numbers. So you have 1, 6, 4, 3, 7, 0, 10, -3, 13, -6, and then the next two. So don't look at the first list. I missed two numbers. So the right list is here: 1, 6, 4, 1, 6, 4, 3, 7, 0, 10, -3, 13, and then we need to figure out, oh, and you have -6, and we need to find the next two. Okay, for this problem, if you look, you want to examine. Let's do the first three and see if we find a pattern. So from 1 to 6, 5 was added, but from 6 to 4, 2 was subtracted. So, and then if we go from 4 to 3, then 1 was subtracted. So there does not seem to be an even pattern there, or a consistent pattern, I should say. So that is not going to work. Looking from one item to the next item and trying to figure out the pattern is not going to work. So the next thing we can do is look at the numbers in a different way. What if I isolate the numbers this way? What if I write, I'm going to look at 1, right? I'll skip 1 and look at the next one, 1, 4, right? And I'm going to look at 1, 4, 7, 10, 13, and then I'll look at 6, 3, 0, -3, -6, and see if I can figure out what's going on here. Okay, so notice what I did. I'm jumping one number right between each one, and then I'm looking at two separate sequences. So if I look at these two separate, maybe I can figure out what's going on here. So if I go from 1 to 4, notice that I'm adding 3 and I get 4. I'm just looking at the first sequence, so I'm going to put a bullet next to each so you can see that there are two separate sequences. So from 1, I add 3 and I get to 4, and then 4 plus 3 gives me 7, right? And 7 plus 3 gives me 10, and 10 plus 3 gives me 13. Okay, so it seems like this is going to work, right? So then that means that the next number, 13 plus 3, is going to be 16 here, right? That's going to be 16. And then let's see if we can figure out what's going on. Sorry about the paper. The camera does some very strange things. There we go. Let's see if we can figure out the next one. So you have 6. If I subtract 3, I get 3, right? So you take 6, subtract 3, you get 3. If you take 3 and you subtract 3, you get 0. Okay? You get 0, subtract 3, you get -3. You take -3, subtract 3, you get -6. And so it seems like it's gonna work. Okay? So I'm going to now take -6, subtract 3, I'm gonna get -9 for the next one. Okay? So then you see how you're able to get, right, the right set of numbers. So here, right, you're gonna get when you write these down, you're going to get these next two numbers, the 16 and then the -9, right? So you can write then -3, you put those together, right next to the 13. This one would be 16 and this would be -9 right here, the next two. Okay, so this one requires a little more thinking. So yeah, some of these problems you're gonna need to try different approaches, okay? And so this one was one of that type. Okay, let's move on to example 5. Let's look at example 5 and see if we can determine the pattern here. Notice that you have a box that is not shaded. Then you have another box that has a small box shaded right at the bottom on the right side. And then the next one is two small squares. I'm going to call them squares, not shaded. And then the fourth one is going to be 3 little squares shaded. So you expect the last one to be all the little squares, right, but not shaded. That would be the fourth item, right? Okay. And let's go ahead and do also number 6, because I think doing these examples is going to help you with the homework. So you want to look at the first 3 items that you have. So I'm going to try my best to draw these. Okay, so you have that. This is given, and I will try to explain right now after I'm done. And then the circle like this with the triangle with the circle in the middle. So I want you to look at the first 3 items before we go to the next 3 items, right? Let me draw the next 3 items. What you have, they're giving you is these figures, and then you need to figure out, so this is a star, you need to figure out the middle one, right? But I'm gonna look at the first 3 items, trying to figure out the last 3 items. Okay, so you have a square with another figure inside, and the inside, when you look at this from left to right, the inside becomes the outside from left to right. Notice that the inside becomes the outside for the middle figure, and then from right to left, the outside, right, becomes the inside. Okay, so the inside from left to right, the inside figure becomes the outside figure, and the outside figure from right to left becomes the inside. So you're gonna do the same thing here. You're gonna follow the pattern given here, and so you're gonna say, okay, so that means that the inside figure is gonna be the outside. So the inside is a cross, so I'm gonna draw a cross outside, and then from here, from right to left, the outside becomes the inside, so the outside is going to become the inside. So you have the outside becomes the inside. So this is the figure you get. Okay, so those are the examples in the workbook for determining or finding the patterns. Now we're going to move on to an example about, so let me show you. This is, you have in the workbook, you have example 6 and example 7, where we're going to be doing apply the given procedure for several different numbers and make a conjecture. So we're gonna make a conjecture based on the observations of how to calculate the numbers. Then you're gonna use the variable n and deductive reasoning to prove the conjecture. So our goal is to prove the conjecture. So we have to come up with the conjecture first, and then we are going to prove the conjecture for the general case, right? So I'm gonna use my own worksheet here so that I have it already ready to go, so that I won't keep you more than, we want to keep these videos shorter than, I don't know why the camera still does. Okay, there we go. We have to keep an eye on the screen here. Okay, so we began, I'm gonna do example 6, and then I'll let you guys do example 7 for practice. So I'll do example 6, and I'm writing 7, I'm sorry. I'll do number 6, and you guys do number 7. Okay? Okay, so it says, the instructions, let me put it on the screen. It says, select a number, add 5, double the result, subtract 4, and subtract the original number. Okay, so select a number. So here is the number selected. We are selecting 4, so they're actually selecting the number for us, right? Notice that this is n. N is the general case. So eventually we're going to get to this, and by proving it for the general case, then we can prove whatever conjecture we end up writing here. So we need to come up with a conjecture, right? Whatever conjecture we end up writing, we come up with, it'll be proven with the general case for any number n. N represents any number, okay? So we're going to start with selecting a couple of 3 numbers, and we're going to apply the process. This is a process that we're going to apply, and then we're going to see how the original number changes when we apply the process. Once again, we take a number. It doesn't have to be 4, it doesn't have to be 9 or 15. These were just randomly chosen. You can do this with any 3 numbers, right? You're going to apply this process. You're going to see what the process does to the original number, and then we're going to write a conjecture based on our observations. We're going to write a conjecture, and then once we have the conjecture, we're going to prove it for the general case using the letter n to represent any number. And that is how in mathematics we prove a conjecture or a theorem, right? We have a theorem, we have a conjecture, and we want to prove it by going through a rigorous process, right? And proving it that it works for any number. We say, you know, let n represent any number, and if we can prove it for n, then we have proved the theorem or the conjecture for the general case, right? And so let's do that. So we take 4 and we're gonna add 5 to it. That's gonna give me 9, right? Then we're gonna take 9 and I'm gonna double the result. So you take 9 times 2, that's gonna give me 18. And then it says to subtract 4. So you take 18 minus 4, and that's gonna give you 14. And I'm going to now subtract the original. So you have 14 minus 4, which will equal 10, right? So then you observe what happened. I went from 4 to 10, right? I went from 4 to 10, which means that what I can see is that the process, right? The process, what did it do? Well, the result of the process is 6 more than the original, because it went from 4 to 10. So it's 6 more than the original number selected. Let's see if it's true for 9. So 9 plus 5, that's going to give us 14. And then we're going to double the result. 14 times 2, that's going to give us 28, right? And then we're going to subtract 4. 28 minus 4 is going to give us 24, okay? And then 24 minus 9, going to subtract the original, is going to give us 15. And so we look at 9 and 15, and again, the process increased the original number by 6. Okay, so the process increased the original number by 6. Now let's look at 15. 15 plus 5 equals 20. 20 times 2 equals 40. 40 minus 4 equals 36. And 36 minus 15 is equal to 21. And so again, the process increased the original number by 6. It looks like the conjecture is going to be that the process increases the number by 6, right? The original number by 6. Well, if we want to prove it for the general case, if we want to prove it, in mathematics, we never prove something with examples. We disprove things with examples. Once again, I'm going to say that we cannot prove something mathematically with one example. We can disprove with an example. For example, if I say every female, every Latin American, every Hispanic female is tall, it is enough for me to find, well, first of all, I have to define tall, right? Let's say that we have a definition for that. As long as I can find one female who's Hispanic, who is not tall based on that criteria, whatever the criteria is, that disproves the statement, correct? So with one example, you can disprove a statement, but you cannot prove something for the general case with one example. It has to be proven with an arbitrary variable like n. So let n represent any number, and I'm going to go through the proof now. What proof? I'm going to prove that the process does indeed end up in increasing the original number by 6. Okay? So you take n and you add 5 to it, and you get n plus 5. N is any real number. And then you take n plus 5, and you're going to double the result. So that means that you're going to take 2 times n plus 5. And remember how to do this. You have to apply the distributive property. So this is 2 times n. That's going to give you 2n. And 2 times 5 is 10. So you end up with 2n plus 10. Remember your distributive property. We went over this last chapter 2, I think it was. Yes. Okay. Now you're going to subtract 4. So you have 2n plus 10 minus 4. That's going to give you 2n plus 6. Right? 2n plus 6. And then you're going to subtract the original number. So 2n plus 6 minus n, you combine the like terms, 2n minus n is going to give you just 1n plus 6. And you look at the result and you see that you ended up with n plus 6. So again, the conjecture that we have is that the process increases the original number by 6 because you went from n to n plus 6. So then you write the conjecture, and this has proved, this last line, this is the proof. Okay, that's the proof, this line right here. So the conjecture is that the process increases the original number by 6. Okay, there's the conjecture. The process increases the original number by 6. And the proof of this conjecture is the last column here. Okay, the proof of this conjecture is the last column. Okay, so here's the conjecture. The process increases the original number by 6. And the proof of the conjecture is the last column because I am proving this to be true for any number. N represents any number. Okay? Alright, so now we're gonna move on. I'm gonna let you guys do number 7. It's exactly the same thing, so you do it so you can practice. And now I'm gonna move on to the last 2 examples because I'm gonna make this video. I want to try to make this video not too long. I'm gonna cover section 4.1 in this video. I am covering section 4.1, and then I'm gonna cover section 4.2 as well because 4.2 is short. Okay, and it's on estimation. Okay, so let me see. So let's see. I'm gonna put this on the screen because it's a reading exercise. It says example 8. It says all of the books written by J.K. Rowling have been made into movies. Okay, so this is a fact. They're giving me a fact, right? They're giving me a fact. So this is a general fact. You know, we know already, we know this. All the books written by J.K. Rowling have been made into movies. They're telling us this fact. Harry Potter and the Sorcerer's Stone was a book written by J.K. Rowling. So, you know, he wrote this. Therefore, Harry Potter and the Sorcerer's Stone was made into a movie. So how is this inductive or is this deductive? Remember, inductive is going from specific to general, and deductive is going from the general to the specific. Well, we're given general information, and then we want to apply that to a specific case, like that new book that he's writing or he wrote, right? So this is going from the general to the specific, which makes a deductive reasoning. Okay. And number 9, it says all of the books written by J.K. Rowling have been made into movies. Like, we know that, right? Therefore, the novel that he is currently working on, so now he's currently working on something, will be made into a movie. So now we're saying we're going from the specific to making a general statement, right? Which is inductive reasoning. So the first one is deductive reasoning, goes from general to specific. And the second one is inductive reasoning, going from specific to general. Okay? So that is the end of 4.1. So we're going to start now section 4.2. And I'm going to give you a definition. So 4.2, this is, we're going to do estimation, graphs, and mathematical models. So what is the definition of estimating? So estimating is what? So let me write it. It means we do the rounding before we solve the problem. We do the rounding before we solve the problem. Okay, so we do the rounding before we solve the problem. So this is the first thing we do. So we don't solve the problem without rounding. So let's try some examples here. And example number 1, it does not tell us what to round to, but let's round each number to the nearest 100 and then add. So let me give you here the instructions. So first, round each number to the nearest 100 and then add. So what are the numbers given? We have 1,175 plus 326 plus 79 plus 5. Okay, so if we are to round, let me tell you what we need to do here. So we have 1,175 and rounding to the nearest, we are rounding to the nearest 100. So we need to identify the 100th place. So you have the ones from right to left. We have the ones, the tens, and the hundreds, right? So this is the place, right? And the same thing here with 326, the 3. So here I'm gonna that's the 1, the 3, and for 79 we have that would be place here, and then for 5 it's gonna be this place here, right? The last 100. Okay, so basically the way that you're gonna do this is you're gonna take a look at the 100 place, and if the number next to it is 5 or more, you're going to increase that number by 1, correct? So the 1 changes to a 2 because the number next to it is 5 or more. It's a 7. So then you write 1, 2, it changes to a 2, and everything else goes to 0. Okay? And same thing here. You look at the 3, and because the number next to it is not a 5 or more, it's gonna remain as a 3. So you have 3 and you change everything to 0. Over here, this is a 0. Think of this as a 0. In fact, you can put zeros there. And so you look at the number 0, right? But you look at the number next to it. If it's 5 or more, you're gonna change the 0 to a 1. So it's gonna be 100. And over here, you look at the 0. You look at the number next to it is a 0. So everything is gonna go to 0 here, right? Because 0 is not gonna change 0 to anything else. So 0. And then you add these, and you have 1,200 plus 300 plus 100 is going to give you 1,600. Okay, 1,600. So this is how you can do this problem. You estimate first, and then you solve. Okay, you estimate first, and then you solve. All right, and so you're going to do this the same for number 2. So you can try number 2 on your own. It's the same process. I'm going to do number 3, and then we're going to go to the graphs. Okay, so let's go to number 3. Let's go to number 3. And number 3, let me read it. It says Juanita pays $3.10 per day to ride the bus back and forth to work Monday through Friday. If a monthly bus pass is $40, is it cheaper for her to buy a monthly bus pass? Okay, so is it cheaper for her to get the pass or to just pay $3.10 per day? Now, she does ride the bus 5 times because it's Monday through Friday, right? So if you look at what she's spending, right? We know she's spending $3.10 daily. Now, because I need to, this section is about estimating. I'm not going to say, okay, well, $3.10 times 5, because she does this 5 days, right? So this is without the pass, the bus pass. Okay, so and please excuse my my spelling. I am not a native speaker, so sometimes I make mistakes when it comes to the spelling. I apologize. I know it's so it's bus with one S, so please forgive me. So without the bus pass, okay, so 5 days. So let's say, because we're gonna estimate, let's estimate to the nearest dollar here. So that's just gonna be 5 days, $3 daily, right? Because I'm gonna estimate. So if she does this 5 days, then per week you have $3 times 5 days is equal to $15 per week. And this is without the pass, right? Without it. Now, if she decides to purchase this for, it says a monthly bus pass is $40 for 1 month, do we is it better for her, right? So in a week, we know she's spending without the pass $15 per week. But if she gets the pass, the bus pass, she is going to get this for $40 for 1 month. For 1 month, right? 1 month is 4 weeks. So this is 4 weeks. So if you take the $40 and divide this by 4, you get $10 per week, right? So she's gonna be spending $10 per week, right? Which is a lot better than spending $15 per week. So it's cheaper for her because she's gonna pay $40 for 1 month, okay? So then a lot easier. I mean, you divide it by 4 weeks, which there's 4 weeks in a month. She's spending only $10 per week. So she should definitely purchase this bus pass, okay? It's a better deal for her. Okay. All right. So you have example number 3. Let's continue. I want to do some of the let's do some of the graphs here. Okay. Some of the graphs. Give me 1 second, and we have okay. Some of the graphs. So you look at this graph. I want to show you the graph here, because that way I'm not gonna draw the graph. Now notice that you have this graph, and this is, it says example 4. The circle graph below shows the percentage of different types of tickets issued by a local police department during a particular year. Now notice you have different categories of reasons for getting a ticket. You have the speeding ticket, you have the not stopping on a red light, on a stop sign, sorry, illegally parking, driving under the influence, and this running a red light, 21%, and then also speeding is 35%. So speeding is the one that has the highest percentage of tickets issued, and then running a red light, 21%, that's the second one, and driving under the influence is the third category, 90%. So we're gonna answer some questions here based on this graph. So make sure you're looking at the graph while I'm answering the questions. And the first question is, what is the most common ticket use, right? This is example 4. Part A, the most common ticket issued was for speeding, okay? Speeding was 21%. 35% of the tickets, of the total tickets. Now, they're not telling me how many tickets were issued for Part A. I just know the graph is telling me that the highest percentage for issuing tickets, right, it says that it was 35%. Now remember, the circle graph below shows the percentage of different types of tickets issued by a local police department during a particular year. So this happened in one particular year, okay? And the most common ticket you issued was for speeding. All right. Now, the next question says, if 19,375 tickets were issued last year, so this was in the year, the total number of tickets last year, estimate the number of tickets issued for running a red light. Okay, so for part B, we know that 19,375 tickets were issued last year. Okay, and we want to estimate the number of tickets issued for running a red light. Now, for running a red light, 21% were issued. So I'm going to estimate that to be 20%. Instead of saying 21%, I'm going to say 20% issued for running red light. So they want me to give an estimate. So if I know it's 20%, it's going to be 20% of 19,375. Well, let's estimate that 20% were issued for running a red light, and let's also estimate that 20,000 were issued in total, because we're estimating. So we can estimate that 20% were issued for running a red light, and we can estimate 20,000 tickets in total. Okay, so I'm making two estimates here. Notice that I'm changing the total number of tickets from 19,375 to 20,000 as an estimate. And I'm also changing the 21% that was issued for running a red light, 21%, I'm changing that to 20%. So then I have to calculate 20% of 20,000. This is what I need to calculate. And if you take, you see that this is going to be 20%, 0.20 times 20,000 gives me 4,000 tickets. And you can say that approximately 4,000 tickets, you can write approximately 4,000 tickets were issued for running a red light. Okay, approximately 4,000 tickets were issued for running a red light. So remember, you're making two estimates here. The 19,375, I went ahead and changed that to 20,000. And then the 21%, because I'm making estimates, the 21%, the actual percentage for running a red light, I changed it to 20%. And then I took 20,000 times, when I say of 20% of 20,000, what am I doing? I'm multiplying. Let me write it on a different paper so you have the written problem here. I'm multiplying. So I'm taking 20%. When I say 20% of 20,000, what I'm doing mathematically is multiplying. So 20%, you can write it as a decimal, 0.20. And then you're going to multiply it times 20,000, which is going to give you 4,000 tickets. These are the estimated figures, okay? Now, this is part B. Now, part C, let's do part C. Part C, it says, if 182 tickets were issued for driving under the influence last month, estimate the total number of tickets issued last month. Notice that they're asking me for last month and not year, and I only know numbers for last year. But you're going to use the same percentages that were given for a year. You're going to use them for the month, okay? So you use the same percentages. You have 182 tickets that were issued for driving under the influence last month, right? And you have to look, you want to figure out the total number of tickets issued last month based on that information. So we know that 182 tickets for driving under the influence were issued last month. So go ahead and make an estimate. So make an estimate and say that last month 200 tickets were issued. Let's say that 200 tickets were issued for driving under the influence, right? So that's the estimated number. Now, we know that what percent were issued for driving under the influence. We know that 90% were issued, tickets were issued for driving under the influence last month. So the estimated number, or the estimated percent, I'm going to make an estimate. The estimate I'm going to make is going to be 20%. Let's say 20% of the tickets issued last month were for driving under the influence. Let's just say. So then you have 200 tickets were issued for driving under the influence. And I know that 19% of tickets were issued for driving under the influence. We know it was last year, right? But we said that we can use the same percentages for the month. We know it was for last year, but we're going to use the same percentages for the month. So we said, well, 90% were issued for driving under the influence last month based on the graph, but I'm going to estimate that to be 20%. And so how do I find then the total number of tickets issued last month? Because they want us to find the total based on these numbers. Well, I'm going to write, and I'm going to write an equation, and I'm going to say that this 200 tickets for driving under the influence equal, okay, 20%, 0.20 equal 20% of the total number of tickets issued last month. And I'm going to use X to represent, the X is going to be the total number of tickets issued last month. Okay, so it's going to be the total number of tickets issued last month. So once again, 200 equal 20% of the total. That's what this equation is saying. So when you solve for X, you're going to isolate this X. You're going to divide by 0.20. 0.20. That gets rid of the 0.20, and so X is equal to, when you take the calculator, 200 divided by 0.20 gives you 1,000 tickets. So 1,000 tickets were issued last month as the total number of tickets. So the total number of tickets issued last month were approximately, because remember that we are using numbers that are estimates, okay? So the total number of tickets issued last month is approximately 1,000 tickets. Okay? All right. So that is example number 4. Make sure you take the time to go over this carefully. All right? And so I want to look at let's look at number 6 to end this video. That's going to be the last problem I do. And remember, this is covering sections 4.1 and 4.2. And let me get another marker because I'm running out of ink. So this example number 6, example number 6. Okay, look at number 6 here. It's I'm going to be looking at this graph. The average cost per year of going to a 4-year institution. One is private, which is the gray color, and the black color is public. So black is public, gray is private. As you can imagine, the private is a lot more expensive, of course, right? So we want to look at some questions here. We're going to look at academic years on the x-axis. An academic year always begins in the fall and it ends in the spring, so that's why you have years 2002 to 2003, because of the way an academic year runs or is structured. It begins in the fall semester, ends in the spring, so that's why it covers the 2 years. So in order to count years, you either begin with the fall or you either begin with the spring. So you have to be consistent to determine number of academic years, okay? All right, so we're gonna go through some questions here. And number A, it says, estimate the change in cost per year in attending a 4-year public, so we're looking at public, that's the black one, public college university from the academic years 2007, 2008 to 2012, 2013. Okay, so what was the change? And when you look at change, you're gonna look at the academic year of 2007, 2008. Well, notice 2007, 2008, we're looking at black, right? So it is approximately, it is 15,000, exactly 15,000 for that first year, 2007, 2008, 15,000. And when you look at the year 2012, 2013, the black here is about, it's above 15,000 a little bit. So let's say that one is 17,500. So what is the change? How do you calculate the change? So in the year, I'm gonna write down 2006, 2008. The tuition was approximately 15,000. Remember, you're looking at public for that academic year. And when you look at the year 2012, 2013, this academic year, it was approximately 70,500. So we are looking at the change. We want to figure out the change in cost. So the change is computed as follows. You take the new year, 17,500, minus the old year. By that I mean academic year, 15,000. And then how many academic years went by between 2006 to 2012, right? You have to see, oh, please forgive me, this was 2007 right here, I apologize. 2007 to 2008, 2012 to 2013. So you see, you can start counting, like I said, starting in the fall. So from 2007 to 2012, that's 5 years. Or you can count starting in the spring from 2008 to 2013, that's still 5 academic years. So you divide by 5 to get the change in the cost per year. So notice this is going to be 17,500 minus 15,000 is 2,500 divided by 5 is going to be $500 per year. So it's increasing. Tuition is increasing at a public institution from the academic year 2002, 2003 to 2013, 2014, right? It's increasing at a rate of $500 per year, okay? Per year. This is question number A. Question number B is similar. Notice what it's going to ask us. If the cost continues to change at that rate, estimate the cost to attend a 4-year public college university in the year 2026, 2027. So it says if it continues to change at that rate. So that means that we need to start at the last academic year, because we're saying if it continues in that same, keeping everything else constant, if it continues to change at the same rate. So going from the last year that we looked at is 2012, 2013, all the way to 2020, what is it, 2026, 2027. How many years is that? It's going to be 14 years. Going from 2012 to 2026 is 14 years. So I know that, how do I calculate the new tuition there? There's an increase of $500 per year. Now times 14 years, right? And then I'm going to add the original value of the 2012 cost. The 2012 cost was 17,000. Back to A here. Back to A. In 2012, 2013, tuition was $17,500. So you're going to calculate if the trend continues, right? If the tuition continues to increase by $500 per year, what do you expect for 14 years from now? Well, tuition will increase. It is now $17,500. Then I'm going to add this to it. So 500 times 14 is going to give us 500 times 14, and then plus 17,500 is going to equal 24,500. So you expect tuition to be 24,500 in the academic year 2026, 2027. Okay? Now you can do this for the general case. Instead of writing the number of years, you can write in a variable here like x, and you write an equation that can give you the value, how much tuition will be, right, in any number of years after 2012, 2013. So that's what the next part is. It says find a mathematical model to find the cost x years after 2012, 2013. That mathematical model is going to be $500 because it's increasing $500 per year times x, meaning this many years after 2012, plus the original value at 2012, which is 17,500, right? So this is the model or the equation. Every time you hear the word model, that's just equation, okay? All right, guys, so that's the last question I'm going to cover from section 4.2. So this was section 4.1 and 4.2. Make sure you do not fall behind. Keep up with your homework assignments and everything, because the course, as you know, runs fast and you need to be on top of things. So if you have questions, remember you can always visit the tutors in Math World, the virtual Math World. You have the link in your Canvas page. The link has the name of Virtual Math World. They're awesome tutors there, very knowledgeable. Or you can schedule a Zoom meeting with me if you have questions. But please do not fall behind. Exam is coming. This is coming. We'll have our first exam week 4. So more details on that. I'm going to release a test review in MyLabs Plus. So you'll get your test review in MyLabs Plus. I'm going to be sending emails, posting an announcement, letting people know where the review will be. Everything is usually in MyLabs Plus as far as homework is concerned and test reviews. And then your exam will not be in MyLabs Plus. Your exam will be in Canvas under quizzes, just like your practice quiz was. And it will require Respondus logged on browser. So if you have not installed Respondus logged on browser, understand that you cannot take this course and pass this course without it, because all exams must be proctored. Okay? So reach out to me if you're still struggling with that, but please do not wait until the day of the exam to let me know that you don't have Respondus. At that point, it's way too late. And by then, it's really way too late. Okay? So, okay, God bless you, and keep up with your homework, and reach out to the tutors or myself if you need help. Thank you, guys. Have an awesome and blessed weekend. Bye-bye.